We have Riko Balakit, and we actually have a BattleBot demonstration here titled Two-Factor Annihilation.
So the project I'm presenting is Two-Factor Annihilation. It's a 3-pound combat robot designed by me. Please save questions for the end. I think that's actually how we're doing all the presentations. And also, there's going to be an extremely loud part of the thing. So I'll give big heads up on that, but cover your ears or grab some earplugs, which are to the left of y'all. All right, so a bit about me. I grew up in San Antonio, Texas. I've been interested in robotics since I was a kid. I did a bit of a First Tech Challenge and some other competitions. I went to Texas A&M, Gig'em, lived in Austin for 7 years. I'm a virtual reality software engineer, currently at TenderClaws, and I've been a member and occasional 3D printing steward for 2 years. So what is robot combat? Basically, 2 robots fight in an enclosed arena for a few minutes. Between 2 to 3 minutes is the usual time. Goal is to knock out your opponent till they're like completely dead, or win the judge's decision after the match is over. And yeah, that is one of the biggest hits that has ever happened. And yeah, it looks awesome. That is Hypershock versus Gigabyte from a couple seasons ago. So yeah, events. BattleBots is the one that y'all have probably heard of. Robot Wars is a really big one, also based in the UK. National Havoc Robotics League is probably the biggest event for a smaller weight class robot combat, which my robot has fought in. And Texas Robot Combat is an organization that just started up again about last year, yeah. And so I'm actually on the TV show BattleBots. This is me over here. This is our 250-pound robot Bloodsport. Yeah, we're actually going to be fighting again in October in Vegas. And so, yeah, weight classes. Here's an overview of the weight classes. BattleBots and Robot Wars and some other competitions, they have the ones that you see on TV are like 250 pounds. And it starts actually at 150 grams. There's actually a weight class called plastic ant weight, which is a variation of the 1-pound ant weight class, which you are only allowed to use easy to print 3D printed materials. PLA, ABS, and PTG are the restricted materials, I think, that you're only allowed to print with. So it's super accessible, super easy. I'll get into that in the end. But yeah, you can get weight bonuses for having walking robots. One event actually gives you a bonus if you have multiple robots. It's a small bonus, but it's pretty significant. And because it is a weight-constrained competition, having safety tolerances and such is a luxury. We are pushing our parts to the absolute limit. So yeah, the various weapons that you'll find in robot combat. Impacting spinners, such as this blade over here. They are the dominant weapon type that you'll find in the sport. They come in 2 main flavors, horizontal and vertical. Both of them have, they're extremely destructive, but they also come at the cost of having gyroscopic precession being an issue, where if it's like spinning super fast, if you try to turn, it'll start leaning over. Sometimes it can even flip itself over for vertical, and for horizontals, it can really mess up trying to drive in a straight line. You have lifters and flippers. They do exactly what they say. They'll either lift up the opponent, drive them around the arena, or they'll flip them and hopefully cause some damage when they land on the ground. If the arena has hazards, which some competitions do, some of them don't, then it can really be a good way to control them. Wedges and rams, those are completely passive weapon types. They're extremely effective. They are very durable. I mean, there's no moving parts, but they are banned from some events because they're considered not very exciting to watch. Hammers are another weapon type. They can be tricky to be effective, but if your opponent doesn't have top armor, then they can be really effective. Flamethrowers are actually a really weird weapon type because for the longest time, they've been honestly really useless. They look cool on TV, not much past that. However, at the smaller weight classes, you'll find that robots are mostly made out of like plastic, and that has been a very recent exploit. Yet you also have some more complex weapons, like a combination of like a hammer with an impact and spinner on top of it. that actually won BattleBots last season. And there are banned devices such as firearms, bombs, EMPs, acid, punching the other driver in the face. Yeah, they're not allowed because they're either not fun to watch or they're straight up illegal or they are unsafe for the audience. But yeah, there is no dominant weapon type. It basically follows a rock, paper, scissors kind of deal, and often you'll have multiple armor configurations or different, even interchangeable weapons if you are going against an opponent that you might be able to counter. And other design considerations, armor and chassis. At this point, those are usually integrated together. They're usually not separate parts anymore. Metals dominate the 30-pound class and higher. You'll have your steels, titanium, aluminum, and magnesium are most common. Plastics, as I mentioned before, are very common in the lower weight classes. And you also have a composite carbon fiber being a very common thing in the lower weight classes. Electronics, most builders tend to end on the extremely safe side with electronics, so they'll actually just run off-the-shelf hardware for RC stuff, like RC cars and drones. Most robots do not actually have sensors, programming, or automation in this sport. It's not like First or other robot sports where that's a very common thing. It's actually very unusual to have that. And drivetrain, the vast majority are just going to be two-wheel or four-wheel drive. More complexity does come at the cost of more weight and less reliability, but that's why some events give you extra weight for that. And so this is my robot, two-factor Annihilation. You can see it on the test box. And so some unique parts about this bot. I mentioned that robots usually don't have programming, sensors, autonomy. My bot is in the probably maybe 5, maybe even 2% of bots that do. It uses a Steam Deck. If you're not familiar with the Steam Deck, it's a handheld Linux gaming computer. For the controls, receiving telemetry and adjusting settings on the fly, this replaces the traditional RC transmitter. Oh, yeah, here's a video.
Controlling this robot with a Steam Deck. I have never seen that before. I'm here with Pearl Gray. Hi. And you have built an amazing robot in two-factor Annihilation.
It looks like a conventional four-wheel drive vertical spinner. What's special about it is on the inside, I'm using custom control boards that are based on ESP32, and so it talks with Bluetooth to a Steam Deck with this app that I wrote in Unity that lets me control the robot. If I move this around, then you can see that it'll actually move around in the UI.
I noticed a little avatar on your readout there as well.
Yeah. So she actually reacts to a different status condition. If the batteries start to get low, then she starts going from happy to and then she's dead.
Walk me through what you're about to do.
Using accelerometers, we're going to see what forces are being applied to the robot.
Oh yeah, she reacts. Yeah. Such cool tech packed into this thing. It's awesome.
Yeah. And so the special electronics, it's based on ESP32C3 with a BNO085 and HRELIS331 IMUs. It has field-oriented drive, which basically, easiest way to describe it is it feels like it's driving like a video game. I'm a game developer for my day job, so I really wanted to feel like that I was driving something as easy as a video game character and not something clunky like an IRL robot. It can have traction compensation for damaged arena floors or debris, negates the gyroscopic precession that I was talking about. It dethrottles the weapon actually when it turns. The electronics were designed in KiCad and manufactured by JLC PCB. I have to make a bunch of spare parts, and while I can do SMT soldering, I don't want to do that 5 times. So yeah, I'll just pay for them to assemble it. It uses Bluetooth LE to communicate, and it has RGB LEDs on the top for status. I have done some rework, though, at Asmbly in the electronics lab, when needed, though. The software, it's a Unity-based application. It runs on the Steam Deck, which acts as the transmitter. It lets me adjust settings on the fly, which is super useful for testing and stuff. And yeah, it has that reactive avatar. The design and manufacture, it was designed in SolidWorks. The 3D printed parts were printed right behind y'all and at home. CF panels, I think, are actually forbidden to produce here because They are carcinogenic, so I have that manufactured by a company called CNC Madness. The UHMW rails, ultra high molecular weight polyethylene, I think. Those were milled at Asmbly on the Tormach back there. The AR500 and titanium components, I ordered those from Suncut Send and Flameform Parts, but we have a fiber laser, which we are getting online for members pretty soon. So soon we'll be able to have those cut at Asmbly. Vinyl decals were cut behind y'all on the vinyl cutter, and custom tires were cast with Vitaflex polyurethane at home. And yeah, so there's my cat on the test box. It also doubles as a footrest. You can see the electronics. They are pretty densely packed in there. And these are the various configurations. The cope cage is used to protect against hammers and hammer saws. This little wedge bot is actually for the event that I competed in Connecticut, which they give you a little weight bonus for multiple bots. So I use that kind of to like set up good hits for me. The one on the left is used against horizontal spinners, and the two on the right are my general purpose ones that have really good ground game to scoop up my opponents off the ground before I deliver the big hits. Yeah, sure, we'll play that. So yeah, that's what I'll be attempting to demonstrate in a bit. The record, it has gone 12 wins, 8 losses, took second place at its debut tournament at Texas A&M last fall. It's fought in Texas, Connecticut, and Oklahoma, and it's finished every event with at least a .500 record. And let's see. Yeah, here's a picture of it after it's most destroyed. Yeah, I was surprised that it was still pretty much in one major piece and not multiple pieces. But yeah, you win some, you lose some. You have to build a lot of spare parts in the sport. And how to get involved. There are several robot parts shops that are dedicated to robot combat. Repeat Robotics and Just Cause Robotics are two shops that are run by my friends. I have a small little shop that has a few pretty specialist pieces. Aggressa and Palm Beach Robotics also sell parts. Just Cause Robotics sells this kit at the top, which is only 2 pounds. So you have an entire pound to expand and build whatever you want to. And Repeat Robotics sells the Peterbar kit, which is on the bottom, and it's extremely destructive. Although you need a test box before you do anything with it at home. Local events include Texas Robot Combat based in Dallas, Texas, Texas Aimbots, which is at Texas A&M, Combat Robotics of Oklahoma, which is based in OU, and Houston area Robot Combat, which is in Houston. But yeah, that's my presentation. I have links here, and I also have stickers, which are up here, and I'll get stuff set up for the live demonstration. Oh, the live demonstration is going to be really loud. Like it's kind of like a quarter or even half the volume of a gunshot. So cover your ears or take some earplugs. Okay, cool. All right, it's all set up. So yeah, just cool. I'll take questions in the meantime. You. Oh, anyone have questions? Raise your hand. Yeah.
Yeah. You said that your bot finished less than 0.5.
Or greater than 0.5.
Sorry. What does that mean?
Oh, that means I won more than I lost, or I won as many as I lost.
Okay.
Yes.
So when you have the extra bot, do you drive both of them?
The question was, when I have the extra bot, do I drive both of them? That's something I've actually considered, but at the moment I have a friend help drive the extra robot.
Everybody got ones that need one?
Oh, question?
Yeah, give us a bit of idea, if you can, how long it took you to start to finish for one of the more recent bots, or how much you end up spending in terms of power, time, and money.
Oh yeah. So cost, there's the kind of general rule of thumb is that the cost of a combat robot's about 100 to 150 pounds, or $100 to $150 per pound, depending on how hard you want to try hard it. And for the time to develop, the first iteration took about 1 month for mechanical design, but I did have the electronics already tested out in a previous robot, my first robot actually, where I basically wanted to iterate on electronics first and then design the next robot around that. So that one was, I want to say, a year and a half, maybe 2 years already of cumulative development time. But yeah, all right, is everyone ready for the demonstration?
Yes.
All right, I'm not kidding, it gets like a quarter or half as loud as a gunshot. Okay. Is the battery low? Oh, okay. I think my battery was actually low. It should have been louder. But yeah, that's, at least I got some hits in. But yeah, how am I on time?
Yeah, so we are about ready to move on to the next presenter.
Alrighty.
Yes, so if anybody has any other questions for Riko, feel free to find them during the breakout session or after the event. Yeah, and thank you for showing us your BattleBot.
Yeah, thanks for letting me present.
Yeah, of course. This is great. The videos are awesome.
Yeah.
Appreciate it.
Oh, and I do have stickers.